Howzik tawdoriba topic ase class 12 p physics ki unit number 1 electrostatics aduna electrostatics se council ki oina di 8 marks lakani. So let us discuss about the electrostatics. So let's see. Unit 1 electrostatics. And it carries 8 marks. Exam the 8 marks lakani sigi unit number 1 dagi. Taseng bai sigi unit number 1 ji the yaw is chapter manga yawi. Ado let's see what are the chapters. Chapter number 1 da khin tamdui je Coulomb's law. Coulomb's law. Chapter number 2 the electric field. Electric field. Chapter number 3 the electric potential. Electric potential. Chapter number 4 the laktu is a Gauss law. Gauss law. Aduka chapter number 5 the tamdu is a capacitance. Ana hariba chapter manga si sigi unit number 1 da koina tamdoi ni aduga exam de sigi manga sidagi chapter manga sidagi 8 marks ni koina laktu is. So first we have to define electrostatics. This electrostatics comes from two words, that is charged particle or electron, and statics means stationary, that is at rest. So let's see. Electro, this electro comes from electron, and this statics means stationary. Stationary. That is, electron means charged particle. Charged particle. This electron means charged particle, and stationary means at rest. Leng dana lay bhai bani. Now electrostatics ta koina tamdui je sagi charge na leng dana layer kan da magi behavior properties ki maram da tamdui ni. So koina electrostatics koina kamai define ta bu yai hairaga di it may be defined like this. Electrostatics is the branch of physics which deals with the study of electric charges at rest. And na koina smaina iba yai electrostatics is koina smaina iba yai the branch of physics which deals with the study of electric charge at rest. Sina electrostatics ki magi one to hai tare definition hai su yare. Electrostatics as a karino hai tare koina smaina pi ba the branch of physics which deals with the study of electric charge at rest. And next we have to define akoi sig first sigi chapter number 1 sigi Coulomb's law je ne akoi tawri je adu Coulomb's law je define tring ai da electrostatics ka related oiba terms duni hana khangda yade aduna important terms related to electrostatics and Coulomb's law duni akoi na hana akoi na discuss tawri je. And next we have to define say electric charge. Electric charge khangda yade id sigi unit number 1 da tamdoi je maroina electric charge at rest neba. Then what is electric charge? Electric charge se karino mu yeng seba ana koina body ma lai tar di magi mass lai ganeba admai to na body ma lai tar di magi charge lai ba yayaba adubu khenari je mass ka charge ka khenari je karino bu mass ti sukso ithu na lai rani body ma lai tar di charge ti lai ba yai lai ta ba yai adu karam kan charge bu da ge phai tar di asagi body du da gi electron je either loss natraga gain tawraba electron pithokraba to but natraga man electron gain tawraba adu charge pro kaneba natraga di body je charge poroi aduna akoina charge kamai define to gibu ma je khoi gi body magi magun neba charge like mass on ko ma je property ni kan property electricity and other related effect can be produced. Electricity natraga na electricity ka mari lena ba effect kaya produced obungam ba adung body du ki property duni, or it may be defined like this. Akoina electric charge se kari no bu sai ma je body du gi magi gun ni karamba gun electrostatic force bi bangamba. It may be attractive or repulsive force in thok pa yai singjan ba yai ko adung ba force bi bangamba body dugi gunduni aduna first we have to define electric charge ko smile define to bayai it is the property magunni property of the matter posakai tare or body property of the matter due to which electricity and other related effects can be produced in it. Body do not produce charge. So electric charge, it is the property of the matter due to which electricity and other related effects can be produced in it. Or it may be defined like this: it is the property of the matter due to which electrostatic force can be exerted. Electrostatic force piba ngamba body dugi magi matter dugi magun dunia koina electric charge haise. Auna kamaina electric charge se puni aduni sar ngasai chai gre ngasai gi charge se transfer tongna body amaga haidi electron je maru ina ko electron je pithok hargana body do kari charge puni ha tadi electron do pithok kitardi asai electron pithok kiba body duna loss to riduna maze positive charge porani adu electron gain to riduna maze negative charge porani aduna charge kamaina pugoda ge phai tar de khoina smaina p bayai the transferring of electrons from one body to another is responsible for charging the body by rubbing, that is friction as I call. Body ani tangnar kanda sagi body do the oriba electrons e transport on the bayaba aduna maram or kanda body singdo charge por payai ana sida khoina khangba yari je body do na karigumpa electron gain toroba electron loction tardi negative charge puduini adu electron pithoki baduna positive charge puduini ko aduna smaina khoina haiba yai when a body gain an electron amma gain toroba when a body gains an electron it will carry negative charge pugani generally electron carries negative charge aduna electron location by the negative charge amakadoini aduna nema negative charge porkani similarly when a body loses an electron, it will carry electron pitoki tardi maje positive charge positive charge. So from this akoina haibi arch kaino bo charge may be divided into two types. Makal ani thona khaitok bayai charge se ahan bada positive charge hama ani subada negative charge haiba. So we may write like this: charge is of two types. Charge akoina makal ani lai haibi ai. Number 1 the positive charge. And Roman number 2 the negative charge. Smile akoina charge makal ani thona khaitok bayai. Then akoina asagi body amada charge se kamaina pugodege haise amokoina maroina makal ani thona khaitok bayai. That is charging by friction habama. Akoina charging by friction id body ani tangnar kanda electron transfer tong duni ko matamdu da akoina charge ko bayai. Sina point number 1 lere ani suba point amusu lai atopa without physical contact between the two bodies a body can be charged. Akoina body and is a contact of the vida when a charge on Mazuya, Sinakari with the charging by induction high. I don't have it palonge. I don't know. A body can be charged in mainly two ways. The first point is charging by friction. Body and internal kind of our charging by friction. The phenomenon of charging a body by rubbing between the two bodies is called charging by friction. Or friction and electricity or friction and electricity. See, the example, for example, say glass rod ka silk takna matamda glass rod na positive charge prokani aduga silk na negative charge prokani ba sigi glass rod siga takna raba ko si rub tor kanda sigi glass rod na positive charge prokani aduga silk sina negative charge prokani ba. And such type of charging a body is called charging by friction. Aduga ani subada charging by induction ai induction hargadi akoina body ani je sukteng thengna davida akoina charge body do charge bondoini and akoina charging by friction da tawdi kaino bo charge buduba body ma charge bu body mo manak ta pusalakba thingdi thengna daba adoi tardi charge buduba body do charge propaya ya ba. Let's see ana sida lakto is number 2 the call charging by induction. Example amana yengsi say let us consider a positively charged body. Sida koina positively charged body mas maina leire lower se si positive charge keri tawdoini body je positively charged body ma atopa uncharged body ma say it may be sphere hai bai ko sphere ma sai manak ta thamdala je sphere ma material sphere ma adita di asagi sigi material spheres da magi free electrons mayam yarungane electrons carry negative charges aduna free electrons sigi spheres yariba electron mayam do asagi positively charged bodies da loi naksalakane usman due to attractive force by charge mayam loi naksalani aduga sigi spheres gi opposite phase atoba mai the positive charge mayam ma lehurane usman positive charge ana sigi negative charges in the sphere which are moving towards the positively charged rod or body are also known as bound charges. Sigi negative charges koina bound charges su kawe. Bound charges. Sida leiba negative charge sing koina bound charges kawe. Aduga opposite side la leiba positive charges sina free charges su kawe koina. Free charges. Karigino hai tardi sigi sphere je koina akoina thing bu le tardi akoina khutna su u tardi sigi positive charges mayam je koi haksang da loina changsilakane aduga art sakhrani aduga sigi positive charge loi mangrane art sam tardi ko smaina for example si art sam da si positive charge se loina si art sangrane ba aduna si je mangrani free charges se adadi han charge from the body je negative charge pure hairane. And such type of charging a body is called charging by induction. Aduna charging by induction is defined the way the phenomenon of, or it may be say, it is at the highest. It is the phenomenon of charging a body by bringing an uncharged body near a charged body. Charge body we manakta charge the body ma pusalak tardi charge pu the body do charge purakane bako adu sugumba charge puhan bagi thawong na kari ko da charging by induction hai ne koina. Next ta koina charge ki magi properties magi magun khara lei adu we discuss tause. Next we have to study about the properties of electric charge. So the properties of electric charge amuk yengsi ana first properties karino bu like charges repel each other, unlike charges attract each other. Hadi mana ba charge ti intok nagani hadi positive repel tagoni, negative repel tagoni aduga positive charge ka negative charge di jingjin nagani haibani. So we may write like this: like charges repel each other and unlike charges attract each other. Next, second point now. Charge, see I'm important about property ni property number 2 je. Charge is quantized. Charge is quantized. Charge is quantized. Then what is meant by quantization of charge? Aduni am important word is. So quantization of charge. Charge is quantized. Quantization of charge is karino bu. Charge body do the yoriba magi total electric charge. Kariga manage bu always equal to integral multiple of charge carried by an electron. That is called basic charge, right? An electron puba charge 1.6 into 10 to the power minus 19 Coulomb dugi integral multiple oini haiba. Aduna quantization of charge karino ana jings ko. Aduna quantization of charge is the property of charge by virtue of which the net or total or we may write net charge, the total charge of a body is equal to integral multiple of charge carried by an electron. That is 1.6 into 10 to the power minus 19 Coulomb. So when the basic charge right go, aduna say quantization of charge say when is minus defined over here. It is the property of charge by virtue of which the total or net charge of a body is equal to integral multiple of charge carried by an electron, that is 1.6 into 10 to the power minus 19 Coulomb. So mathematically we may write like this. Say, let capital Q be the net or total net charge of a body. Then, according to quantization of charge, we have quantization of charge total charge se kari manane ba integral multiple of charge carried by an electron. So we may write like this: plus minus NE, where N represents integer. There's 1, 2, 3, 4 like this, and E represents basic charge, that is charge carried by an electron, that is magnitude of charge of an electron 1.6 into 10 to the power minus 19 Coulomb. Now see the plus minus it is if the body carries negative charges, then we have to use negative integer, that is minus 1, minus 2, minus 3 body do not negative charge body endo negative integer and if the body carries positive charges, then we have to take positive integers plus 1 plus 2 aduna sida plus minus it is and plus minus it body do the lady but charge to gi maka pole, that is positive charge we gonna positive integer negative charge we gonna negative integer aduna sigi formula je yamna important oi aduna sigi formula the base kan da koina exam da calculation gumba dum hangba yawi. So C Q equal to plus minus NE. So charge is quantized later, property number 2 the next property number 3 amu yengase. Charge is additive. Kari hai badu dia. Charge is additive. That is additivity of charge. Charge khoi body amada magi body dugi magi tongan ba jaga sing liba charge mayam je akoina loina tinjanaba yaganeba, so that we can find out the total charge of that body do the lady but total charge to putoke hargadi body dugi magi tongan ba jaga da liba charge mayam do plus toroba algebraic sum toroba adoi tardi body dugi total charge fangani haibani akoi dum tinjanaba yahayab aduna we may define like this: additivity of charge tells that charges located at different places or regions of a body can be added plus the way I have, so that net charge, the total charge upon the charge of net charge can be obtained. For example, example say body ma se swaida smile let us consider a body. Sigi tonga ba jaga da man charge kar pure lowerji say it may be plus 2 Coulomb, it may be minus 5 Coulomb, it may be plus 1 Coulomb. Smile lower say. So these are the different charges located at different points or different regions of a body. Then in order to find out the total charge of this body, we can add all the charges, that is total charge to ke hai tardi my total charge mai la ne ba plus 2 later sida plus minus 5 mai la ani punje la kodini ko plus 1 mai la ne ar si loina plus tawradi kya tare koina minus 2 tare 5 minus 5 plus 3 aduna magi net charge se minus 2 Coulomb hai ne ba. So we can find out the total charge of the body by simply adding all the charges located at different places or different regions of that body. Point number 4 the muk lasi. Say Roman number 4. Charge is conserved. Then what is meant by conservation of electric charge? Charge se conserve oi habani ana kari hai no mai je conservation of electric charge hai kino bu sagi body ma tongana lejaraba charge di pu charge di yaw adadi atopa body singjuga ma samnadrab isolated oiragadi body du the yoriba total charge se always constant, that is remain unchanged masa matanta na hongjaba ngamdeba increase obusunga moi decrease obusunga moi aduna remains constant lini haibani. So we may define like this: charge is conserved. Conservation of charge is the property of electric charge that tells us the total charge of an isolated body total charge of an isolated body is always constant. That is, we may write remain unchanged. Aduna so charge body ma tongan leragadi magonda leriba charge to adum fixed oini havani constant oini havani sina charge is conserved or conservation of electric charge. So these are the common properties of electric charge. And when the properties of electric charge tagi exam da lakpa ya question kara ai sarna pige ana what is mean by quantization of charge. See one mark that exam da hang bayawe ani suba question da what is mean by additivity of charge. See so one mark that hang bayai. Then what is mean by conservation of charge. Sumaina hang bayai aduga yamna chambada write the numerical value of a proton or electron. Sumaina hang busiawe and answer di proton may charge di electron ko samane but proton carry positive charge and electron carry negative charge ni 1.6 into 10 power minus 19 coulomb. Sumaina dum hang busiawe yam isam samna. Then numerical problem da based on quantization of charge. Sumaina hang bayai. Can a body carry 3.2 into 10 to the power minus 20 coulomb of charge? Give reason or why have it may carry 2 mark. Body amada sigi charge 3.2 into 10 to the power minus 20 coulomb of charge leiba yabra yai hargasu reason pi doini yadre hargasu reason pi haibani reason pi bagi to 1 ma leire aduga sigi yes or no kumbagi 1 ma amaga aduna masagi akoina quantization of electric charge to gi magi mathematical form duni apply to duise, that is total charge q equal to plus minus n ido ana sida pdz total charge q do oiduni akoina putok doisina n do integer do n do akoina solve tor kanda integer fangaba adu tar the answer je yes haiduneba body duna sigi charge se carry to by n haiduni integer fangdradi no haiduneba. So let's see ana sigi solution is my lani sida pyramid is given total charge silai total charge ni avna q represents total charge of the body minus 20 coulomb smile ane ed charge of electron di moidi isana du khangjar dawni madi non values ni exam da superior moy avna electron gi mana puriba magnitude of charge se 1.6 into 10 to the power minus 19 coulomb ne, and we have to find out n, that is n is integer oibra oidabra so akoina ji yeng tuine ana sida lak tuise we have q equal to ne using quantization of SARS. Quantization of SARS. Now, sida ko na n putuk hai tardi q divided by e smailan. Ana q sinjalo e sinjalaje. 3.2 into 10 to the power minus 20 divided by 1.6 into 10 to the power minus 19. 3.2 the 1.6 na divide already 2 taramani. 2 into 10 to the power. Makada le riba 10 to the power minus 19 ze matakta numerator da poradi plus la ne. Adadi 10 to the power minus 20 plus 19 lakh tardi 10 to the power minus 1 phang neba. Say is minus 20 plus 19 smile lakh 20. 10 to the power minus 20 plus 19. Then you'll get 2 into 10 to the power minus 1 lakh neba. Adi 2 into 10 to the power minus 1 id 0.2. 0.2 tare. Adi 0.2 jidi integer nate. Madi fraction la hai. Aduna body do the sigi charge se puba yara roi na hai duine. Aduna si integer na trebo. Which is not an integer. Which is not an integer. See integer not trebo. Now, the conclusion the PDC kainobu. Hence, a body cannot carry this much of charge. Hence, a body cannot carry 3.2 into 10 to the power minus 20 Coulomb of charge. Smile pirani answer se. So mathagi topic ta yamna maruiba topic hai tare sigi unit number 1 sigi, that is Coulomb's law of electrostatics yam koina discuss tawse. Ana Coulomb's law of electrostatics na PDC karinobo magnitude of electrostatic force between two charges. Charge aniki marakta leiba force tugi magi value potokpada sigi law je koina season avna koina let's see charge ani lower say q1 and q2 akoina sigi charge akoina generally point charges haine point charges. Then what is meant by point charge? Point charge iti karinobu sagi charge tugi size tuga charge ani tugi arapa distance tuga compare tarukanda distance tuna ka hena chawgraba size tugi adita charge toina point charge hai. Aduna let us consider 2 point charges q1 and q2 separated by a distance r lamna leiba aduga charge ani na leiba medium je koina it may be ear oiba yai ear ne na koina generally loba yai ear medium the charge ani lei lower se adita the Coulomb's law na higher se karinobu sagi magnitude of electrostatic force between two charges. It may be attractive or repulsive force. Singjin nagera itok nagera kaisukaide on a charge ani gi mark leiba force se karida depend togebu charge ani dugi product purina buga directly proportional oigani aduga charge ani dugi arap dugi distance square duga inversely proportional oineba. Haibadi charge ani du yamna chawring gai makoi ani gi product purina bugi value yam chaw kadi ana force chaw kani haibani aduga distance duga di inversely proportional oi. Charge ani dugi arapado yam chawring gai force to picture kani haibani adamana is the square ma yagoni distance square ta bije square na ta is kaino bu distance kitang henkalakpada lapthok labado kitang chawkalakpada force di yam hena decrease tor kani haibani aduna akoina sumaina piba yai Coulomb's law of electrostatics se I stand means it states that the magnitude of electrostatic electrostatic force either attractive or repulsive. Between 2 point charges is directly proportional to the product of magnitude of two charges and inversely proportional to the square of the distance of separation. Distance of separation between the two charges. So this represents statement of Coulomb's law of electrostatics. So let it write mathematically. Mathematical form the muk sigi figures gi matung ina muk easy. So we may write like this. Let Q1 and Q2 be the 2 point charges separated by a distance r in ear. Charge na leriba medium da koina ear in lower se as shown in figure. According to Coulomb's law of electrostatics, we have magnitude of electrostatic force between the two charges is given by, let it denoted by capital F. Charge ani mark leba force akoina capital M na represent orji and pagi statement gi matungina F is directly proportional to product of the two charges, that is Q1 into Q2, and inversely proportional to square of the distance between the two charges, that is R square. Sigi forms ni magi Coulomb's law na sida ko ita pidise. Then sigi relations akoina equation da onto payai by putting an appropriate constant ama siga chana ba constant ama half kan da koina equation oina ito payai. So we may write like this: F equal to K. Generally constant is denoted by small k. K. Aduna masagi force, electrostatic force may be K into Q1 Q2 divided by R square, where K is the constant of proportionality. Constant of proportionality. How does he constant say? Ako'y namukari ka managebo. Wow. Equal to 1 by 4 pi epsilon naught. sida lariba symbol si e na te ko si je epsilon kawe epsilon hai akoina Greek letter ni epsilon adu sida akoina 0 amata pije sina akoina not hai epsilon not sigi epsilon not sina represent toriba physical quantity je amuk kari no bu absolute permittivity of air or vacuum air na vacuum gi absolute permittivity represent toba adu symbol ni epsilon not hai je adu absolute permittivity hadi kari no bu asagi nuksit na tangna vacuum da electric fields na or electric line of force na kayam phajana sat pangam ge haibdo sigi value na lep toine aduna sigi k se kari mana ge bu 1/4 pi epsilon naught adu magi numerical value na my value di kari mana bu 9 into 10 to the power 9 my value je adu unity sidagi puthokpa yani k gi unit se k haibadi 1/4 pi epsilon naught se anu sidagi f haibadi force di newton da measure tawi magi SI unit se r di distance ni that is meter da measure tawani aduga charge q1 q2 di coulomb da measure tawi aduna k gi unit puthoke hargadi sidagi hoina phangbaje newton leire sigi radius square je left da poradi meter square la ani sigi q1 q2 je left da poradi makha da coulomb square legarni aduna newton meter square per coulomb square newton meter square per coulomb square sumaina lane next da sigi epsilon naught se karino harunge sigi formula je sima leire again we may realize this epsilon naught represents absolute permittivity of air or vacuum adu my value di approximately sidagi dum puthokpa yai 1/4 pi epsilon naught se 9 into 10 power 9 ga manare adu di sidagi akoina epsilon naught ki value je calculate torkanda approximately 8.85 into 10 to the power minus 12 unity sigi inverse sigi onat aina boilani that is newton per meter square coulomb square smaina tar ana sida hairiba constants gi values di akoi isana by heart tok tare hayeng exam da Coulomb's law of electrostatic ta based over numerical problem hang targadi sigi constant gi value je question da piramoi akoi isana khangjagadobuni aduna sigi value je kawba yati sigi makhada mu smaina koina lasi k gi value je sinjala jeba sta pirije so this implies that f equal to q1 q2 divided by 4 pi epsilon naught r square sidale ba k je koina 1/4 pi epsilon naught se sinjala kanda masagi Coulomb's law of electrostatics se koina finally we may write like this maina koina pirane simalaira ara sigi formula sima kawba yadre then atopa point amana charge ani gi marka leiba force that is electrostatic force se koina central force harga ju khangnai gravitational force adidi electrostatic force se central force harga ju khangnai then what is mean by central force idi kaino bu ngasagi direction of electrostatic force always directed along the line joining the two charges charge ani samnariba line do adugi direction du da force lega da uneba sigi particular figure is the yengseba if q1 and q2 are two positive charges ani oitar di moise repulsive force odineba adadi ani ji inton by force atopa direction da satpa yaroeba aidi som da satpa yaroeba kari gino hai tardi modi central force hargadi charge ani samnari straight line do adu da lega da uneba haidi sigi spina either som da line ne repulsive force ko charge ani samnaba line du da lega da force sigi force ki direction is minor piba yai natragana som da smine leiba yai atopa direction da piba yadi so sigi points ma khang tare sagi electrostatic force se central force oi central force idi kaino sagi electrostatic force ki direction je charge ani samnari ba line do na lady ba direction ai tare adu lai ga do ne electrostatic force between two charges ki values di akoina Coulomb's law je apply toroga sigi form je pala putok pa yar ne. Then again force se akoina vector quantity ni my direction lai, then how to find out the direction of electrostatic force between two charges adu tar de koina Coulomb's law je vector notation vector from the previous year aba I direction ga loina na pi ba yai and mathang da lak tu je hoji yeng se Coulomb's law of electrostatics in vector notation.